Alright, so for today's notes, we're going to wrap up our unit with functions. So far we've talked about what functions are, we've talked how to evaluate functions, and we've also looked at how to transform functions when you're moving them or shifting them. The last thing we're going to look at is doing the average rate of change of a function. So to start that off, we've got to start off with just reviewing slope. So today should be a review from algebra from last year, or 2 years ago. So what we're going to look at today is called the slope formula. And I think everybody will remember this once you see it. It's just going to take a little bit of practice, but it should be a pretty easy day to follow with the material. So remember, slope is just the ratio of the vertical change to the horizontal change. And that's between any 2 points on a line. So it's the ratio, which means a fraction, a comparison, of the vertical change to the horizontal change between any 2 points on a line. So how you've probably seen slope before is rise over run. So we're comparing the change in the vertical, the up and down, to the horizontal. And sometimes you'll see the symbol delta y over delta x. And the letter they use for slope, hopefully remember, is m. So when you're graphing, you use the slope m. So there's a formula that we use for m, and it really goes back to this definition. It's the change in y, so it means you take the y values, y sub 2 minus y sub 1, and you subtract them over the change in the x values, x sub 2 minus x sub 1. Remember, when you list a coordinate, the coordinates are listed as x comma y, so the x1, y1 is just the first coordinate you're looking at, and the x2, y2 is the second coordinate you're looking at. Okay, so let's look at some examples. Let's move the camera down. All right, so a couple examples here. So when you're looking to find slope, you're finding the change in the y values over the change in the x values. So let's say I give you these 2 points, and I ask you to find the slope. The first set of points is negative 13 comma 8. And the second set of points is 3 comma 12. So what I like to do when I'm using the formula, remember our formula is right up here, I'm going to label these values. So in my coordinates, I've got my x1 and my y1, because this is the first coordinate I'm looking at, and then my x2, y2, because that's the second coordinate I'm looking at. So now all I'm doing is applying these numbers into this formula. I'm just plugging them in. So I'm taking my y2 value, 12, and I'm subtracting my y1 value, 8. So it's 12 minus 8 over my x2 value, 3, and I'm subtracting, and this is a mistake a lot of people will make, my x1 value, which is negative 13. So notice I have two negatives here. I'm subtracting the negative. So now when I simplify this, 12 minus 8 is 4. That's my change in my y values. Over 3 minus 13, that becomes 3 plus 13, so it's 4/16. 4/16 can be reduced to 1/4 because I can divide the top and the bottom by 4 to simplify it. So the slope between these 2 points, the change in the y values over the change in the x values, is 1/4. We use slope when we get to what's called average rate of change. Let's do 3 more examples together, and then I'll have you work on the practice problems on your own. So number 2, again, it'll be find the slope. And this time, we'll list the coordinates 7, 3, and 6, 4. So I'm going to label my x1, y1, because that's the first coordinate, my x2, y2, because that's the second coordinate. And now I'm just going to do my formula. So remember my formula, just slide over here for a second. Here's my formula, y2 minus y1 over x2 minus x1. I'm going to apply that in this problem here. So I'm taking my y2 value, 4, minus my y1 value, 3, over my x2 value, 6, minus my y1 value, 7. So 4 minus 3 over 6 minus 7. So I've got 1 over negative 1. So this winds up simplifying to be negative 1. Let's take a look at another example. Find the slope. This time I'll list my coordinates as 2, -5, and 2, 10. Alright, so same idea. I'm going to list my coordinates x1 and y1, x2, y2, and we're going to set this up. So I'm going to take 10 minus -5, so 10 minus -5, over 2 minus 2. So 10 minus -5, that turns into positive 15 because that's 10 plus 5. 2 minus 2 is 0. So when you get a fraction like this with 0 in the denominator, this is called undefined. You cannot divide by 0. So the slope between those 2 points is undefined. And then our final example, I'm going to ask you to find the slope between the 2 points. So we'll do 3, -5, and 10, -5. So same idea. I list my x1, y1, x2, y2. So my y values, I have -5 minus -5 over 10 minus 3. So negative 5 minus negative 5, that turns into negative 5 plus 5, so that turns into 0 over 7. So when 0 is on the numerator, I can divide, that just gives me 0. So the slope of that line would be 0. So that's the slope formula. So to find slope, you identify the x1, y1, and the x2, y2 of your two coordinates, and then you just subtract the y values divided by subtracting the x values. We're going to use a slope formula when we move on to finish functions when we do rate of change. So I just wanted to make sure we reviewed that. So now you can try the practice problems in class.